This will be the given question. They will give this kind of a graph in your examination. Either they might be named as some S, T, X, Z, any kind of alphabet. If not that, you have to rename it, and by default they will give the source node. No need to assume the source node here. They will give the source node in this kind of a problem. So here, after you got this kind of a problem, the first step is that you have to rename all the nodes. I assume that they haven't given any kind of a name, so except the source node. So I renamed the first node as R, that is this node as an R, and this as an S. This will be the source node, and this is the T, this is X, and this is Y, and this is Z. In this problem they have given the source node as S. This they have given, so remaining nodes are renamed with some other alphabet, and this is the path value, that is edge value they have given, and from this I have to trace from source node to the all other nodes. That is the given question. Now the first step is that we have to find, in the step 1 we have to find which is the source node and where the outgoing paths are reaching. So if this is the source node, whatever the nodes are there prior to this one, that is this R, will be ignored. We'll be starting the path only from the source node, so that whatever the nodes which are there prior to this source node, that will be ignored. This node will be ignored. Now we are dealing with the first step. In the first step, we have to initialize the source value as 0, and all other node value as infinity, and all other node value should be infinity. So in the first step, find the path from the source node to outgoing node by changing the source node value as 0 and moving to other nodes. After getting the optimized path, then we need to relax the respective node values. That is, let's make the source node as 0, and all other remaining nodes as infinity. Now we are starting from the source node. Now we have to find whether is there any outgoing arrows from the source node. So here you can find from the source node, yes, we have two outgoing arrows, that is from S to X, the outgoing arrow, as well as from S to T. These are only two possible outgoing arrows in the source node. Now we have to relax these two nodes, because from S to T it is infinity. Now S to X it is infinity. Whether can we relax this node value by any other values instead of this infinity, that we need to do now. Now we are done with the step 1, that is we have to initialize the source value as 0 and remaining node value as infinity. Now we are done with the step number 1. Now we are moving for the step number 2. Now we are going for a step number 2. In the step number 2 we have to find the optimized way, that is from S to the outgoing arrow, that is T, and S to the outgoing node to the X. Now 0 is here, infinity was there. Now 0, the S value, the source node value, plus this edge value will be the node value. That is S value is 0 plus 0, S to T value is 2, so that will be 2. So this node value will be 2. 2 is better than infinity, so we are fixing the T value as 2 now. Now we are going from S to X. 0 plus 6, it is 6. Now we calculate it from the source node. Source node can reach only from S to T one way, and one more track is S to X. That's it. We are not reaching either Y or Z. Why? Because S is not directly connected to the Y or X. S is only directly connected for only T and X. So whatever we have calculated the new track now, that we have to shade. This one. And this one. So there ends the step number 2. Now in the third step, we have to find the next possible output paths. That is, we already done with the source node. Now we are reaching to the next node from the source, that is T node. Now the pointer will be in the T node. From the T node we have to find the optimal solutions. That is, what are the possible outgoing arrows from the T which is reaching the remaining nodes. Now we have the T can reach X, we have the output arrow now, as well as T is having the two more output arrows, that is T is reaching Y, one output arrow, as well as T is reaching one more output node, that is Z. So Therefore, that node T is having possibly 3 output arrows. Now we have to find the optimized value for these 3 node values. Now it was infinity, infinity, and it is 6. Now we have to update whether we can find any other feasible node value for these nodes. Step number 3, we are in the node T. T to x, x is already having the value 6. Can we reduce this 6 with any other value that is less than 6? Here 2 is there, 7 is there. 7 plus 2, it will be 9. But 9 is greater than 6. So 6 is feasible one. So we are not replacing this value with any other value. Now we are moving for the next value, that is T to y. T to y. Earlier it was infinity. Now we have to update this y value, that is 2 plus 4, that is 6. For the next track, from T to z, T is 2 and z value, node value, it was infinity. Now we have to update that. So edge value is 2. So 2 plus 2, it is 4. Now we're done with the 2 more new values. So we have to shade that value, the root. These are the newly identified roots. Now we are going for a X node, as we are done with the source node in the first step, and the second step we are done with the T node. Now we are going for the third next step, that is step number 4 for the node X. Now we could reach this X directly from the source node, as we have the shortest path of S to X with a value 6. Now we have to find whether is there any outgoing arrows from the node X. Yes, we have 2 possible outgoing arrows for the different nodes. X can reach Y, we have the direct path, as well as X can reach Z, we have the direct path. Now we have to check that whether we can optimize this Y value and Z value with any other feasible values. Now we are tracing that. I can reach this Y from the T with the cost of 4 and making this as a 6. Can we optimize this value 6? Yes, we can do that. How means here the X value is 6 and this root value is -1. So 6 minus 1, that is 5. That 5 is less than this 6. So we are optimizing this Y node value, that is by 5. This 5 is less than 6, so we are updating the node value of Y by 5 instead of 6. Now we found a new root to the Y instead of this costlier one. So we have to avoid this root, we have to ignore this root, and we have to darken the new root, newly found root. This will be the optimized one. Now we are done with the one calculation. We are going for the next one, that is X to the Z. X to the Z. Already we have 4. Already we have the 4, the direct one value. Now we are checking from X to Z. X to Z. X is 6 plus 1, that will be 7, but 7 is costlier than this 4, so we are not doing any changes for this Z value in this step. So we found the new value from X to Y, as well as ignoring the root T to Y. This one we will be ignoring. Now we are going for the next step, that is for the next value, that is next node is Y. I have to find any other feasible values I can found from this node value to the different nodes. So the outgoing arrows will be Y to Z, only one arrow is there, so we have to find whether is there any other feasible values. Here the Z value is 4. Z value is 4. Can we able to find any other feasible value which is less than 4? Now if we trace that, it is 5. 5 minus 2, 5 minus 2, it will be 3. 3 is less than 4. Now we found a new value 3 which is less than 4, so we have to update this Z value. So 5 minus 2, it will be 3. Instead of 4, it will be 3 now. So we found a new value for the node Z as well as the new track, and we have to ignore this root. At the end of the all 5 steps, we found with a final answer, that is a final solution for this graph. That is, this is a source node and this is a source node having the node value 0. This is the next node T having the node value 2. This is X having the node value 6. This is Y having the node value 5. This is Z having the node value 3. This is the optimized solution for this particular graph. So through this through this shortest path tracing algorithm, we found the easiest as well as the feasible track from one node to the other node. This will be the final solution for this problem. If this kind of the problem has been asked in the exam, you have to follow the stepwise answer. For here I took some 5 steps. You have to follow the same procedure for this kind of a problem. It will be having some 5 steps, so totally it could be asked for some 8 marks.